Hello everyone, myself Muthu Nadarajan from the Department of Mechanical Engineering at Kamaraj College of Engineering and Technology. Today we are going to see a topic called center of gravity. So this is one of the important concept in the subject engineering mechanics. So we will be seeing what is the center of gravity. So center of gravity is nothing but it is a point in which the whole weight of an object is assumed to be concentrated. In simple terms, what we can say is, let us consider this as an example for a book. Okay, so there is a book which consists of a length of 10 centimeter and a height of 20 centimeter with a thickness of, let us consider, 2 centimeters. Okay, so there is a book in which its length is 10 centimeter, height is 20 centimeter and the thickness of the book is 2 centimeters. So how to find the center of gravity? So center of gravity can be placed anywhere. Okay, so it is nothing but it's a simple, in simple terms, it is a point in which the total weight of the object is assumed to be concentrated. So let us consider the weight of the book is, say for example, 2 kgs. So we can balance the book in a particular point. So we used to do in normal classes like so we can balance the weight of the book in a center point. So we can't balance the weight in any other location apart from the center. So that particular point, okay, so the point at which the total weight of an object is assumed to be concentrated, that will be called as center of gravity. So it's a point which is not to be in the exact center. So it's a point where the total weight will be assumed to be concentrated. So that's what center of gravity is all about. Now let us consider it with an example. So here I am giving you an example of L section. So first of all, when we need to solve a problem related to center of gravity, we need to find how many sections are there in the object. So for here we will be considering two sections, section number 1 and section number 2. So there are two rectangular sections that has been assembled together to find out or to produce this L section. So what I am going to say is, we are going to find out the location of the center of gravity. So it's simple, it's a point in which we have to find out the x coordinate as well as the y coordinates. So that point the total weight will be assumed to be concentrated. So here there are two different sections. So section number 1, so from here to here the height is 150 mm, whereas this length is here 10 mm. So I am going to find out the value of x as well as y. In addition to that, we need to find out the area. Okay. So for this section, where is the x axis? Here the x axis is placed in the bottom position as well as the y axis is in the leftward point. So here the y axis is placed and here the x axis will be placed. The objective of finding this x value is like we need to place this y axis in the center point. Okay, in this, for this particular section we need to move the y axis to the exact center. So here the length is 10 mm, so 10 divided by 2 will be 5 mm. Then the y value will be calculated by moving the x axis towards the center. Okay, so this distance will be the value of y, so which is 150 divided by 2, that will be 75 mm. Then the area for the rectangular section, as we all know, it is very simple, length into height, which will be 1500. Similarly for section number 2, so this is the section number 2 from here to the end point. Okay, the length is, the total length is 100, in which we need to subtract 10 mm. So here they have given 10 mm. So we need to subtract, so that we will be getting 90 mm and the height will be 10 mm. So here also we need to account that the axis, x axis is placed in the bottom. So there is no change here. So the x axis will be placed here, whereas the y axis, now you can clearly see the y axis is 10 mm towards the left side of the base point. Okay, so I am going to place the y axis here. So this gap is 10 mm. So the objective of finding the x values, y values will be like, this y axis has to be moved to the exact center of the particular section. So here the x axis has to travel freely for a distance of 10 mm So that has to be added, and then the gap is 90. So I will be putting like 90 by 2, that will be 45 plus 10 will be 55. Similarly, the x axis has to be come to the center. For that, the height is 10 divided by 2, that will be simply 5 mm. And here also the area is 90 into 10, that will be 900. Okay, so this is what the basic points we need related to center of gravity. Then finally, how we will be calculating the x bar and y bar value is, in simply we can write the formula as a1 x1 plus a2 x2 divided by a1 plus a2. So what is area 1? So this will be the area of the section number 1. So the a1 will be 1500, x1 will be here. For the first section, x value is 5. So that will be 1500 into 5 plus the area 2 is 900. So 900 into x2 will be 55 divided by the summation of areas, 1500 plus 900. So after calculating these points, we will be getting the value of x bar. So this is the center of gravity with respect to x axis. Similarly, we need to find the y axis value, in which we can simply change these values, like this x1 will be replaced by y1 and x2 will be replaced by y2. So simple. So area 1 will be same for the particular section, y1 will be 75, that has to be placed here, and the 5 mm which is the y2, that has to be entered here. After solving the problem, we will be getting the value of y bar also. So the x bar and y bar is nothing but, it is also a point, it is also going to represent a point which will be placed somewhere here. So this is the point where the whole weight of this particular object is assumed to be concentrated. So we will be calculating the location of the center of gravity here. So this is what the basic problem in center of gravity. So likewise, we can solve many different problems using different sections. So that will be discussed in the upcoming videos. So thank you.